Right, hi everybody, my name's Ian, G0XBU, and today I'm going to talk about what's behind a WebSDR. As most of you probably know, I host the Jodrell Bank WebSDR and also the Clee Hill WebSDR, which is on Tidstone Clee Hill. Unfortunately, that one's offline at the moment due to expensive mobile data costs, but I'm trying to work on a solution for that, so watch this space. So a little bit about me. Licensed since 1996, although nobody's reading this because now you're looking at the photographs. Ex-Formula One radio telemetry engineer, so I've been to every single Grand Prix, I think at least 3 times. Which is pretty cool, and I came back into amateur radio when the SDRs caught my attention. I kind of like modern technology, and I love the fact that you can view things on the waterfall. Things like that was quite good. So it got me back into radio. So a quick sort of basics on SDRs. Software-defined radio is what it stands for. Basically, that means that the software does the radio bit. There's no mixers, filters, amplifiers, etc. That's all kind of software controlled. What really is, so the likes of the smart SDR, that's the newer LEC, that's the dongle at the top, that actually stands for SMA-RT. What it's basically doing is it's converting the RF into audio signals. And from that, it then obviously connects to a PC sound card, and it sends via USB to the PC sound card. So inside the dongle is a analog to digital converter, ADC also known as. It's about 8 bits on the dongles. The RSP1A, for instance, is 14-bit. Some of the latest SDR rigs, like the Flex radios, the Anan, the Apache Labs Anans, they're 16-bit, and they sometimes include more than one ADC. So they can actually kind of listen to various. They've got effectively 2, 3, 4, 5, 6, 7 receivers, so they can listen to signals at the same time, basically. Obviously, we don't do that with the WebSDR because we use WebSDR.org software, and that's actually limited to 8-bit. So even the RSP1A, which is a 14-bit system, gets knocked down to 8 bits in order to work with the WebSDR.org software. So basically, the dynamic range, the ADC dynamic range, is directly related to the performance. So that basically means that a weak and a strong signal together in the passband, the higher the dynamic range, the better that processing is. So you can have strong stations and you don't get too much ghosting and intermodulation. So that's kind of what you're paying for with the higher end dongle or even the RSP1As, etc. It's that dynamic range that's important. The dongle has fairly minimal RF filtering. They're pretty wide as standard, because what's basically happening is it's receiving everything. It's only showing you 2 megahertz, but it's able to receive everything in one go. So if there's any strong signals completely out of band of where you're receiving, for instance, the likes of broadcast radio, they're going to make their way into your passband. So basically you need to filter that out. Now the likes of the RSP1A, they've got this built in. They've got sort of filters for broadcast radio, etc., DAB radio built in already. But the trick with the WebSDR is to add extra filters for the bands that you want, which is fairly straightforward and kind of common thing with amateur radio enthusiasts. Basically, the more you pay, the better you get performance-wise. So, I mean, the dongles range from about £25 upwards, I think, and they're brilliant for what they are. They only go down to about 25 megs. Below that, you then need a converter, an up converter, which effectively receives below sort of 0 to 25 megs and then retransmits it at about 125 megs. And then all you do is you tell your dongle to listen at 125, but tell the software that's HF. That's how the same way a transverter works, really, but in the opposite direction. So yeah, very good. As mentioned before about the 14-bit ADC and the RSP1A, that's kind of the holy grail really of the WebSDR, the RSP1A, but obviously they're expensive. They're about £100 each. There's currently 3 on the Jodwall WebSDR and there's 1 on the Klee WebSDR. So I keep trying to add them as I can. But it's just a case of, it's only a hobby, so you've got to do these things as and when. The basic design is fairly straightforward. You plug the antenna into the dongle. You then plug the dongle into the USB port of the PC. It happens to be a Linux PC which runs the WebSDR.org software, and the Linux PC then connects to the home router. The signal to noise ratio is the most important part of it. So antenna, signal to noise, low noise floor. This can be achieved by various filtering, mains chokes. It's the kind of basics that the best thing to look at for this is GM3SEK's work on filtering. I've kind of studied that and tried to add his chokes and his mains filtering, and it's worked quite well really. The Jodwall Bank antennas are situated quite a long way from houses and things, so it doesn't suffer too badly. Now and again it gets a few bits, but not too bad. But the idea is then to notch unwanted signals, strong broadcast, things like that. Like I say, RSP1As have got that built in, but you can add extra filtering. The PC itself, the max number of bands you can have on one PC is about 6. Obviously, that depends on the performance of the PC, but on the ones I'm using, which are the Dell Optiplex 980, about 6 is a max it can handle. Obviously, you need a decent amount of USB ports in order to achieve that, or use the kind of hub. But what I've found with the USB hubs is they tend to kill the audio quality. Because obviously you plug in everything into one USB port, and it's trying to cope with all that sort of audio and all that bandwidth. So I found it better to plug them in directly into each USB port if possible, and that seems to work the best. It's one dongle per band. Each dongle will only do about 2048 kilohertz, so 2 megs. That's what you see. You can lower that. You can't really go much higher than that. It's about its maximum, but you can drop that down if you want to sort of make the available bandwidth shorter and maybe try and blot out some unwanted carriers and things like that. But what can then happen is you lose some of the band, and I notice some other WebSDRs do this, and you don't get all of the band, and that's a bit of a pain, really. Some people want the CW section of a band, some people want the top end. For instance, 80 meters, CW at the bottom, top end is all the DX. Now, if you just have the middle section, yeah, you can hear everybody chatting and things like that, but then you don't get the extremes. So I feel that you need the full bandwidth, even at the expense of noise. Speaking of noise, the dongles are pretty sensitive to it, as mentioned before, with them having quite a wide receive. They're pretty sensitive to dirty USB connections and things as well. So I must admit, there's a lot of messing and unplugging and plugging things back in and trying to sort of keep the noise levels down. It's an ongoing thing, really. Onto the software, which is in the Linux PC. It basically runs the WebSDR.org software, which Peter's done, PA3FWM. If you Google WebSDR.org, you'll be able to read a bit more information about his work. Very clever chap. He's now got his doctorate, I believe. So good on him, and I'm really pleased that he's come up with this software, because it means that we, as enthusiasts, can use it. So it works on the principle of a TCP, so it's a TCP server. Web servers all built into his software, and then various instances of TCP connect to the dongles, and then to the overall software, and that's what you're connecting to when you log in. I've got 7 instances of this TCP running on the Linux PC. and then the web server itself as well. So it's quite a busy PC, really. You can tell from the bottom it gives you the CPU load, and it's pretty maxed out depending on how many visitors are on the site. The basic HTML web page design, as you can see from my work, I've done a lot of changes to that to make it a bit more sort of visually appealing. That's come mainly from Roma SDR in Italy. The chaps there have done a brilliant job on theirs, and I asked them if I could borrow their template basically, and then modify it for my own personal tastes. So the work's not all mine; it's mainly theirs, and then I've just tweaked it here and there. So, but brilliant! It looks really good, I think, compared to the standard one you get. The standard port's 8901, and then each time you add a dongle, you just change the port to not a dongle, a PC. You just change the port to the next available one. So you can have as many PCs as you want with various bands on them. So like for instance, the Utah site, they've got 3 or 4 PCs, I think, running various different bands, and then you just change this port. The only thing then is you need the port to pass through the firewall, so you need to sort that out on the router, which I'll move on to next. So it's just a standard router, but it needs the port forwarding enabling in order to let this port through so that visitors can access it. The biggest issue I'm finding with the Clee Hill site is obviously the port forwarding doesn't work over mobile networks, because mobile networks use a thing called CGNAT, I believe. It's like a double natting, a network address translation, and it doesn't allow this through because you're not getting a public IP address with a mobile phone effectively. So you can buy, which I did have, the fixed IP SIM card, plug it in, away you go. That worked a treat, but the cost was ridiculous, just too expensive for a hobby, really. So that had to be terminated, and now I'm looking for another solution, which is going to be along the lines of a VPN connected to the home broadband. But if anybody knows any solutions, please drop me a message, and it'd be great to get that one back up and running very cheaply. Like I say, it's got to be a fixed IP, really, or you could use DNS, I guess. But these are all things I need to kind of look into. So yeah, that's the kind of basics of the design of it. So the Jodrell site, some pictures here, antenna systems. This is now slightly out of date, actually, because I've changed this to a 3-element Yagi, but you get the idea. It's on a 60-foot tower, which I raise up and down depending on the wind conditions. We've got the collinear on the top. We've got the CB antenna. We've got a little mini whip. There's a delta loop that runs in a giant triangle in this kind of direction. So yeah, that's all the antenna situation. That comes down into various switches. So I can switch between my own shack radios and the actual WebSDR. So sometimes I'll transmit and I'll flick these across. So most questions are, what happens with the WebSDRs when you transmit? Well, the simple answer to that is they don't like it. So the best solution would be some form of TR switching, so transmit receive switching, so that you can stop the RF getting into it. Recently I've just killed the up converter because it didn't like 400 watts. The antenna, I've got a DX Commander style homebrew vertical here with an inverted L for 80 meters, which runs down and sort of terminates above the shack, and obviously it didn't, the Hamit up converter didn't like the 400 watts, and it's taken it out. So you've basically, the answer is you shouldn't really be transmitting with the dongles connected, so it can cause them damage. The switching helps because these ground when you switch them, but it's not the ideal solution. In the box we've got the various dongles, and we've got the RSP1As switching. So we've got a duplexer here for 270. We've got that's then split. The RF splitter here splits the UHF signals for 446 and for 77s. Here is a LNA basically, so an amplifier preamp. But what I've now done is this is now gone up onto the tower. So it's actually a masthead preamp. It was this picture was taken as I was testing it downstairs. So that's a bit better for signal to noise on UHF and VHF, and it has made a bit of a difference actually. These are 6 dB pads because the gain from the preamp is just too high. The poor old RTL dongles can't cope with having that much gain. They just completely overload, and you get loads of ghosting and things like that. So I've had to attenuate it. So we've got a total of about 12 dB attenuation there. You get about 4 dB attenuation with the splitter. So yeah, it's been required. The Clee Hill site is a bit more simple, straightforward collinear. It's only about 6 meters high. We're on this tower in the middle, which is a weather radar tower here. We've got the computer inside a rack. It's all temperature controlled in there, which is good. Basic dongle and an RSP1A as well. And like I say, 6 meter high antenna, cheap collinear, not that much coax. It's the CNT 400 coax, are pretty good stuff. But I mean, we're 507 meters above sea level here, so the views are stunning and the RF location is amazing. So really need to get that one back up and running again, really do. Right, the user interface, as I kind of touched on earlier, is I've changed the HTML on it. It's based on HTML, CSS, and JavaScript. Now it's been a big learning curve for me trying to learn, all about these 3 programming languages, because I didn't really know much about it. So it's been brilliant. But yeah, learn a bit now. The JavaScript side of it's all kind of done by Peter and then it's just been personalized. And the WebSDR community is great because people are sharing information, and other WebSDR hosts who've got a bit more knowledge are sharing their kind of work. And one example or 2 examples is the Utah WebSDR. So Clint over at Utah's done a lot of work with the DSP, audio DSP and stuff. So that's great to get all that incorporated. And Bass ON5HB. He's done a lot of work on the drivers required to get the RSP1As working with this WebSDR.org software, and again a fantastic job, and the latest one is the best one he's done, which gives you sort of better low weak signal receive when there's a strong signal in the passband. So that's a really good feature as well. Behind all of the software is this main config file. There's config file, there's waterfall scripts, there's the sound JavaScripts, etc. All can be modified. The config file gives you the basics like the bandwidth and the device you're using, and you can change the color of the waterfall and the signal strength. You can calibrate the signal meter as well from it, but I tend to do mine based on color, because for me a WebSDR is all about the kind of view, the image, not really the signal strength. So when you look at a signal strength on an SDR, WebSDR, I wouldn't really believe it unless the hosts have calibrated it properly. Some do, some don't, but for me it's more of a kind of visual appeal. So I'll change the colors to make it obvious to see signals rather than based on what their signal strength is. So that's worth bearing in mind when you're going through it. But yeah, I've made a note of a few people who've helped with mine to get things working. Like I said before, Roma SDR, Clint at Utah, Bass, NA5B, and Paul GAHXT. There's a tuning bar that you can just about see it on this picture. Stretches up and down, and it's really good because you can drag that then, and it shows you where your frequency is, and that's really nice. Just little things like this, little tweaks and improvements are nice to add in. And then finally, we've got the Pocket TX app, which Dan Y03GGX has come up with, which is another great feature. Basically, that requires an XML file being installed on the PC, which you then add in the frequencies that you're covering, and all that happens is that goes off to Dan's server, and then he's able to put your WebSDR on his kind of server for his RxTX app. And yeah, that's all it requires. It's quite a simple process to get your WebSDR on the Pocket RxTX app, but not many sites do it in the UK. My Jodrell one's got it. I've not put it on the Klee one yet, just because of the extra bandwidth it will require on the data link, and obviously because of the the cost of that, I've not bothered. But it's something I can look in the future, and it will be a very easy task to get it installed. But yeah, take a look at that. It's a good one for using when you're out mobile. Failing that, there's a mobile version of the site. If you log on with a mobile device, you'll get a warning at the top saying you're on a mobile device, and you can click on that warning, and it'll open up the mobile version of the site, which is a very cut down version, slightly different. I've tweaked it slightly as is what I like to do. So it's actually quite a good little mobile version of the site. But yeah, by all means, check it out. Right, that's pretty much it. There's a little snapshot of the Pocket RxTX app. Yeah, take a look at that, and quick look at the websdr.org config file. So we've got a basic snapshot of the config. Like I said before, you can tell it what device you're using, you tell it what frequency to start on, sample rates, center frequency. The program frequency is if you're using an up converter, you add that in. Tell it what antenna you're using. Gain is the color of the waterfall, and signal strength. Allow wide effectively just means you're allowing it to somebody to expand the bandwidth up to maximum about 8Ks, I think. So for people using the ESSB, that's quite a useful extra. Extra zoom, never use it. The computer can't cope with it, basically. That's if you want to really zoom in on the waterfall, but it doesn't like it. Noise blanker's not very good at all. That's to get things like electric fences out, but as you can see from mine, it doesn't seem to do anything. So, and then this is a quick snapshot of the TCP instances that you have to open up in order to get the thing working. So this is an example of the RSP, which is RSP1A1, and yeah, you basically that's the start string, and then it comes back with all the things that have been set. You can change all of these with different strings, but or you can just leave that all blank, and it will just default to the the basic settings. That's it. I hope that was useful, and many thanks for watching. Catch you on the next one.